Okay, welcome Cloud Gurus, and congratulations for making it this far. You've done a great job. This is the final white paper. This is the last thing you need to know before going into the exam. This white paper is called Architecting for the Cloud Best Practices white paper. So really it starts by exploring the business benefits of cloud. There's almost zero upfront infrastructure investment. You get just-in-time infrastructure, so you provision something using auto scaling. It can basically detect if you're starting to get overloaded and provision infrastructure just in time so that you don't have an outage. You get more efficient resource utilization. You get usage-based costing, it's otherwise known as utility billing. So you're only ever paying for what you need, or you're paying, by the hour. There's no, 3-month or 3-year or 10-year contracts. Although you can get contracts with reserved instances, but when we're just using our basic on-demand instances, it's just usage-based costing. And you get reduced time to market. And this is why a lot of startups start on the AWS cloud platform. You can traditionally, before the cloud became mainstream, you would set up a website, say in the US, and suddenly you wanted to expand out to Japan and offer something very similar. You would have to go in and find a data center space in Japan, get physical kit ordered there, get it all configured. Generally, you'd have to either fly out or use remote hands. Whereas now you can just go in and using things like CloudFormation or Elastic Beanstalk, you can provision entire data centers programmatically in entirely new different regions, so you completely reduce time to market. In terms of the technical benefits of cloud, you've got automation, which is what I was just talking about, scriptable infrastructure, and the world is really changing. The role of infrastructure architects is now becoming, infrastructure architects are slowly dying out, and now we're having to become software architects, so we're having to learn how to script infrastructure rather than actually physically go out and purchase it. You've got auto scaling, which is a massive benefit of AWS. You've got proactive scaling. You've got a more efficient development life cycle, so things like continuous integration or agile development. You can basically continuously update your code and push it out to the cloud, and you have your software release cycles as being every hour, or and you can just update features, whereas traditionally it used to be that you would release a new version of Windows or a new version of your application, which would take many months to do, but with the cloud you can now use you can use continuous improvement. You've got improved testability, so you can have testing and development groups that are completely separate to your production environment. You can test immediately to see whether or not you are able to push this out to production. You've got disaster recovery and business continuity. In the Route 53 lecture, we looked at how we could fail over a site from entirely different regions automatically within a few seconds. And you can overflow the traffic to the cloud, so you don't necessarily have to have your entire production environment in the cloud. You can do things like provision additional web servers and add them to your in-house load balancers, for example, so that if your traditional infrastructure that you've already invested in, you're already locked into contract in, and you don't want to necessarily move it all to the cloud initially, but it might not be able to handle a marketing event that you're doing, you can overflow your traffic into the cloud. This little graph comes up inside the white paper, and it's a really cool graph. So it basically shows you elasticity. If you look at your y-axis, we're looking at the infrastructure cost, and you look at your x-axis, you look at time, and then the little black dotted line is your predicted demand, so you can see it sort of scales linearly. If you look at your red, that's more, the red line is more what your real or actual demand is, so it moves up and down, up and down, up and down. Now with a traditional base infrastructure, you would be basically scaling up, so you would buy, let's say, 3 servers, and then you're going to hit a a bottleneck, and you're going to have to scale those servers up. So you might increase the amount of RAM in them, you might add CPUs if they've got spare sockets available, you might add additional disk space, etc. So that's what we mean by scale up. And then in order to if you then look at the brown line, this is scaling out. So you would add, you might have 3 servers, then suddenly you need 4 servers, suddenly you need 5 servers, etc. So the way it moves is it's very it's moving at 90-degree angles essentially. You've got to spend money at particular points to meet demand. It's not very flexible. Whereas if you look at automated elasticity, you can use things like CloudWatch alarms or SNS. You can set alarms so that if you're suddenly hitting 80% CPU utilization on your web servers, you're going to need an additional web server that will automatically be provisioned for auto scaling. And then when that web server falls below, let's say 20% CPU, that's automatically decommissioned. So that green line is what Amazon offer you. It's the automated elasticity, and that really is why it's such a powerful platform. And this is why it's not just Amazon. This is for any cloud provider. But it's why a lot of people are now moving to the cloud, so you don't have this massive capex cost that you're just spending money that you don't necessarily have to do. With any cloud-based products, you can now do it basically on demand. Control your spending on demand as and when you use it. The white paper then talks about design for failure. And this is a really great principle, and you should really live by this. The rule of thumb is be a pessimist when designing architectures in the cloud. Assume that things will fail. In other words, always design, implement, and deploy automated recovery from failure. In particular, assume that your hardware will fail. Assume that outages will occur. Assume that some disaster will strike your application. Assume that you will be slammed with more than expected number of requests per second someday. Assume that with time your application software will fail too. By being a pessimist, you end up thinking about recovery strategies during design time, which helps in designing an overall system better. And no one does this better than Netflix. Netflix have developed their own software called the Simian Army. So they have things like Chaos Monkey and Chaos Snail. Chaos Monkey will just go in and randomly delete instances on the AWS platform. So just go in and terminate an instance, and it's there to deliberately design, to deliberately fail parts of the Netflix service. And Netflix, they design for failure, so they have these tools on their production environment. I'm not kidding; it really is on their production environment to go in and start causing trouble, and they have to design around that. Similar with Chaos Snail, that's designed to go in and slow down their services. So if you design for failure, it means that you've got a much better chance of being up rather than being reactive as to when something does fail. Decouple your components. Whenever you see decoupling, automatically think SQS. As soon as I see decoupling in the exam, that's the first thing I look for in the multiple choice sections is SQS. The key is to build components that do not have tight dependencies on each other, so that if one component were to die, sleep, or remain busy for some reason, then the other components in the system are built so as to continue to work as if no failure is happening. In essence, loose coupling isolates the various layers and components of your application so that each component interacts asynchronously with the others and treats them as a black box. For example, in the case of web application architecture, you can isolate the app server from the web server and from the database. The app server does not know about your web server and vice versa. This gives decoupling between these layers, and there are no dependency code-wise or functional perspectives. In the case of batch processing architecture, you can create asynchronous components that are independent of each other, and again, they're just talking really about SQS. That's what's going to sit between your web server, your application server, and your DB server. Implement elasticity. So the cloud brings a new concept of elasticity in your applications. Elasticity can be implemented in 3 ways. So there's proactive cyclic scaling, or cyclic scaling. This is periodic scaling that occurs at fixed intervals. So this is basically if you know that at the end of every month that your website is going to be busy. Maybe it's because payday comes out and you're running a site that for a cinema and people want to go out and buy movies, then you'll proactively scale up your web servers to deal with the month-end load. So it's based on a cycle, and so that's where you're proactive and you're doing it either manually or automatically, but it's based on cyclic scaling. Then there's proactive event scaling. This is scaling when you're expecting a big surge in traffic requests due to a scheduled business event. So think of new product launches, think of marketing campaigns, think of Black Friday, think of Christmas, for example. This is where you're going to proactively scale based on a specific event coming up. And then the third one is auto-scaling based on demand. And this is by using a monitoring service, your system can send triggers to take appropriate actions so that it scales up or down based on metrics. And the one we've been using was CPU utilization, for example. And the last interesting part of this white paper was just secure your application. So you have different security models depending on what tier. So if your web tier, you would allow port 80 and 443 open to the internet. For your application tier, you'd only allow SSH, and that might be deliberately locked down to just your static IP address or to an IP range that you set. Or you might be connecting in via direct connect, and then you deny all other traffic to things like your database servers. So that really sums up this white paper. Have a read. It is quite an interesting white paper, especially if you are an existing solutions architect or if you're wanting to get into solutions architecture, but I have covered off the main points. So congratulations, guys. You've done really well getting through this far into the course. And the next lecture, we're just going to talk about the exam practicalities, what you can expect on the day, what you need to bring, etc. And then that's it. You're done. Thanks a lot.